What's up, geometry scholars? In today's class, we're going to use properties of sides and diagonals to identify if a quadrilateral is a rhombus or a square, or maybe it's just a parallelogram. And we're going to be working on a coordinate plane. And I can't help but notice that on today's worksheet, it says right at the top, coordinate geometry. And I created this document to help us out. So this is going to be maybe a little bit of a cheat sheet or a reference guide. And I know at the top we've got the slope formula. We've got formulas to help us determine the length of a side or a diagonal. We've got the distance formula, and we've got the Pythagorean theorem. And we've also got the midpoint formula, which is going to help us identify if diagonals are bisecting one another. So here's what I know. We've got the properties of parallelograms, which I know that you guys know by heart. We've got properties of rectangles, properties of rhombus, a square. At the bottom of the worksheet, I see that there's some information about trapezoids. We're not going to worry about that yet. Instead, what we're going to do is we're going to spend a little bit of time on question 19, where we've got quadrilateral JKLM. So the first question says, given the set of vertices, determine whether JKLM, this quadrilateral right here, is a rhombus, a rectangle, or a square. Looks like we've got three options, right? And it says list all that apply. And then critically, it's asking us to explain. And so when I draw my attention to this diagram, I can say with some degree of certainty, right, that this is not a rectangle. This is not a square because it doesn't have those telltale 90-degree corners. This is an obtuse angle. So I can say that most likely it's a rhombus, but what we're going to need to do always is explain. We're going to have to prove that it's a rhombus, and to do that, we're going to use this handy-dandy coordinate proofs cheat sheet. And so what do I know? It's got to be a parallelogram, right? But is it a rectangle, a rhombus, or a square? Well, let's take a look at the properties of a rhombus. So it says that how to prove it's a rhombus. Well, the first criteria is that it's a parallelogram. And so how are we going to prove that this is a parallelogram? We're going to use the reasons above. And so let's draw our attention to the top of the sheet. Properties of a parallelogram and how to prove. We've got four options. We can prove that opposite sides are parallel using the slope formula 4 times. Alternatively, we can use opposite sides are congruent, opposite angles are congruent, but we're not going to be doing this actually on coordinate grids because I'm not going to go into it. We're going to hold off on that option. But the last option is proving using the midpoint formula that diagonals bisect each other. I'm going to keep it relatively simple, and I'm going to show that opposite sides are parallel. And to do that, we're going to be applying the slope formula 4 times. So let's jump right on in. And how exactly is that going to work? How do we start? Well, I'm going to start first with identifying the slope for side JM, and then I'm going to do KL, MM, ML, and then JK. Okay, beautiful. So if this is a slope that we're trying to identify, and again, we want to show that opposite sides are parallel. We want to prove that JM is parallel to LK. Simply, we can take a look at the handy-dandy cheat sheet, and I can see that we got slope formula to change in Y over the change in X. Or simply, we can just identify the rise over run visually. And so I know that we're going to start here. We're going to count up 1, 2, 3, 4. Okay, so it's 4 up. And then how many to the right? 1, 2, 3. Beautiful. So we've got a slope of 4 over 3. That totally makes sense. What's the slope of KL? We're going to start at K. 1, 2, 3, 4. 1, 2, 3. Again, we've got 4 over 3. And so it looks like we've got two sides that are parallel. Is ML and JK parallel to one another? Absolutely. And I know that because what's the change in Y values? It's not going up or down. It's 0 over, it looks like 5, and 0 over 5. So that's going to be what? A 0 slope. And clearly, these are not forming perpendicular angles. And so we can rule out that this is a rectangle or a square, but we still got to prove that this is a rhombus, right? And so how are we going to do that? Well, we're going to need to, let's figure out if all 4 sides are congruent. And so we're going to use the distance formula or the Pythagorean theorem. And so the first thing that we're going to figure out is the distance of segment ML. And so that's this segment right here. And you know, we actually don't even need to apply the distance formula, although we could, and we certainly don't need the Pythagorean theorem. Instead, we can just count because it's sitting right on this horizontal axis, and I'll just count visually, right? 1, 2, 3, 4, 5. Beautiful. And what about segment JK? 1, 2, 3, 4, 5. Beautiful. All right, so the distance of ML is 5. The distance of JK is 5. What about JM? All right, so this is a little bit trickier. So we've got two options. We can apply the distance formula, which is the change in x squared plus the change in y squared. And then you're going to take the square root. Alternatively, we can apply the Pythagorean theorem, which we remember is a squared plus b squared equals c squared. C, of course, is the hypotenuse. And so what I'm going to do is we're going to construct a triangle. You can do it on the inside or the outside of this parallelogram. And I know that in this triangle that this is forming a right angle. And so what is the length of this leg? And then what is the length of this leg? So this top length has a length of 3. And I can see that this is 1, 2, 3, 4. All right, and so let's apply the Pythagorean theorem. Okay, so instead of a squared, we're going to do 3 squared. B squared is going to be, or B rather, is going to be 4 equals c squared. And again, we're trying to figure out what is this hypotenuse right here. This is the length of the side, and that's what we're trying to figure out. We're going to keep our fingers crossed that it's 5 because that would yield all sides being congruent. All right, so let's simplify. 3 squared is going to be simply 9. 4 squared is going to be 16 equals c squared. 9 plus 16 is going to give us 25 equals c squared. And then we got to get rid of that exponent. So we're going to take the square root of both sides. So c equals 5. That is amazing. All right, so we know that JM, side JM, is going to be also 5. And I know that when we take a look at the right side, what do we have here? We've got another triangle where we've got a side length of 3 and 4, meaning that this length here is 5, 5, 5, 5. All 4 sides are congruent. That's amazing. All right, so what do? We just proved that this is a rhombus because why? Because opposite sides are parallel and because all 4 sides are congruent.